Okay, this question is about resolution of vectors. So let us just look at these two diagrams that we have here. Suppose we are trying to construct a rectangle whose adjacent sides lie along the x and y axes. How could we specify this? There are two ways to specify it. One is, say, I've got the length of the diagonal and the angle that the diagonal makes with the x-axis. That is this figure on the left, where OA is the diagonal, and that's the length of the diagonal that's been prescribed for us, and theta is the angle, the orientation of this diagonal. You can see, as soon as I have an orientation and a length, the point A is fixed with respect to O. As soon as the point A is fixed with respect to O, I can drop a perpendicular from A onto the x-axis, meeting at AX. This is a unique point. There is no ambiguity about what it is. It is the single foot of the perpendicular from A onto the x-axis. Similarly, I can drop a perpendicular onto the y-axis, and the foot of that perpendicular will be the unique point AY. The rectangle OAXAAY is uniquely specified, therefore, by the length OA and the angle theta. Another way of going about it is to say specify the actual lengths of the adjacent sides. So I could specify that the side along the x-axis has a length OAX, and the side alongside the y-axis has a length OAY. As soon as I have that, all I have to do is from AX I construct a line perpendicular to the x-axis, and from AY another line perpendicular to the y-axis, both of those lines meeting at the point A. Now, since there is only one line that is perpendicular to a given line, both AYA and AXA, that is the perpendiculars from AY and AX, are unique lines, and therefore their point of intersection A is also a unique point. And therefore again we get that the rectangle OAXAAY is a unique rectangle. It is easy to see from the two figures that they are the same rectangle also. From the construction, it is easy to also see, using trigonometry, in the triangle OAXA, with theta being the angle AOAX, that AAX is the line is the side opposite theta, and OAX is the side adjacent to theta, and therefore OAX will turn out to be OA cos theta, that is the adjacent side is the hypotenuse times the cosine of theta. Similarly, OAY will be OA sin theta, that is the opposite side is the hypotenuse times sin theta. This is just basic trigonometry. So from both these diagrams we see that there is a relation between the magnitude OA, the orientation theta, the side along the x-axis OAX, and the side along the y-axis OAY. Resolution of vectors is all about these two ways of representing a rectangle. So let's go ahead with some more formalized ideas. So consider a vector r bar. Let's say its magnitude is r and its orientation with the positive x-axis is theta. The vector resolves into an x component along the x-axis and a y component along the y-axis. Okay, and then we can say that r is rx, the x component, I hat, plus ry, which is the y component, j hat. And using the trigonometry from the previous slide, we can say that that would be r cos theta. The x component is simply r cos theta, and that into I hat, plus r sin theta, which is your y component, and that into j hat. Another way of going about it is, suppose we're given the x component to be rx and the y component to be ry. Using Pythagoras' theorem, I can find the magnitude. Yeah, so the magnitude r is simply the square root of rx squared plus ry squared, and then I can find the orientation using tan theta is ry by rx, and that gives us cos theta to be rx divided by root rx squared plus ry squared, sin theta to be ry divided by square root of rx squared plus ry squared. It's simple, basic Pythagoras' theorem, nothing fancy. Okay? And now it is easy to see that rx is actually this square root multiplied by this, which is basically r cos theta, and ry again is this expression, which is r sin theta. And once again we get r bar is rx I hat plus ry j hat, which can be written as r cos theta I hat plus r sin theta j hat. So basically, if we have a vector of magnitude r oriented with respect to the positive x-axis with an angle of theta, then the x component will be r cos theta, the y component will be r sin theta. That is the way we resolve a vector along the axes.